Hello, this is Nick Andre welcoming you to the Screencast. In this screencast, we will learn how to create a DHCP server using Packet Tracer. We will also explore the client-server relationship formed when a new end device is added to a network. In this exploration, we will discover the 4 steps required for automatically assigning an IP address to a client. To begin this exercise, I'm going to work my way down to the lower left corner and click on End Device. Holding the Control key, I'm going to click on the very first generic icon called PC PT. I'm going to let go of the Control key, come up to the logical workspace, and click 3 times, thereby dropping 3 unique PCs, PC0, PC1, PC2. Okay, after I added these 3 PCs, I'm going to press the escape key so my cursor goes from a skinny plus symbol to the traditional white cursor. Now to connect these 3 PCs together, I'm going to need an intermediary device known as a switch. So I come down here, I'm going to click on the second icon of the first row, and I'm going to choose the very first icon, the 2950-24. I'm just going to place this right above PC1. Now that the switch is added to my logical workspace, I'm going to connect the PCs to the switch. So I come down to the lower left corner, I click on the lightning bolt, and for the interest of saving time, I'm going to hold the Control key and click on the Auto Connect feature. Letting go of the Control key, I'm going to click on PC0, I'm going to click on Switch, then PC1, then on the switch, and then PC2, and once again back onto the switch. So my 3 end devices are connected to my intermediary device, in this case the switch. I'm going to press the escape key, so now I'm back to my standard white cursor. And I'm going to give it a second or two for these orange lights to go green. Once I know they light up in green, that these 2 devices are communicating, that is the switch and the PCs, each have their own established connection. So as you can see, PC0 now has a green light, PC1 now has a green light, as well as PC2. Normally, I would go into a PC and configure it with an appropriate IP address at this step. However, the goal for this lecture is to learn how DHCP automatically assigns an IP address to an end device. In order to learn how DHCP works, I have to set up a server. So once again, I'll come back down to this lower left corner. I'll click on End Device, but this time I'll click on the 3rd device over called Server-PT. I'm going to take the server, add this component right above the switch, and now that I have my server added to the logical workspace, I can connect it to the switch. Once again, come down here to the lightning bolt. I'm going to click on the Auto Connect. This time I'm not holding the Control key because I'm only connecting 1 device to the switch. So I click on Server 1 and then I click on Switch 0. And as before, this end device will have to negotiate with the switch, determining what type of cable it is, probably working out spanning protocols, all of which are beyond the focus for this screencast. So I'm going to click on the fast forward time just so that everything all lights up in green. Now that all my end devices have green lights where their mediums are connected to their components, I can go into my server and configure it. Remember, I'm not configuring these PCs, PC0, PC1, PC2, because they will be getting an IP address automatically assigned to them by the server. So to configure the server, I'm going to click on it once. A dialog box should appear. Name of the dialog box is the name of the device I clicked on, in this case Server 1. I'm going to click on Desktop. Remember, the server's responsibility in this case is to give out IP addresses, so it's probably a good idea to configure this server to have a static IP address because it's going to be giving everybody else an address. So let me click on IP configuration, dot next to static. And in this exercise, I'm just going to use 192.168.1.0 I'm going to say 253. I'm going to click on the subnet mask, and I should have my standard 3 255s followed by a 0. I'm going to leave these two fields empty for now. We'll come back later and adjust them accordingly. Now that I configured the server to have an IP address, I can configure the service that's running on the server to be able to hand out the appropriate IP address for this network. That is the 192.168.1.something address. So let me click on config, and over on the left side you will see a list of services that are available for us in Packet Tracer. The service we're learning about in this screencast is DHCP, Dynamic Host Configuration Protocol. Let me click on this service. I'm going to verify this service is turned on. Remember, I don't have a gateway on this local area network. It's just 3 end devices plus a server and a switch. As a result, I really don't need to configure these two pieces of information, the gateway and a DNS server. Because I configured this server to be part of the 192.168.1 network, DHCP has assumed that that's the addresses it should be handing out. I'm going to modify this just slightly. I want the starting address to be 30 in this network. Next thing I'm going to do is I'm going to change the number of users that I'm going to dynamically assign. In this case, I'm only assign 100 users from this pool. Typically, different organizations have their own set of rules, but they take their address block and they'll divide it up to 3 categories. One for a dynamic set of addresses, another one for managed devices like switches and hubs and whatever they might want to try to keep track of, and the last one for static devices, permanent devices that belong to the physical essence of an organization like servers, printers, possibly IP phones, routers. And so in this case, I'm taking the pool, the block that is 192.168.0, and dividing it up into 3 parts. The first part, from 0 to 30, I'm going to leave for my managed devices. The next part, from 30 up to 130, I'm going to be using for my dynamic range. And then the last part, 131 all the way up to 254, I'll be using for statically assigned addresses. So let me click Save. And let me click Close so I'm back to my logical workspace. Let's see DNS in action. In order to do so, I'm going to verify that I am in real-time mode. And then I'm going to click on PC 0. I'm going to click on the Desktop tab. And then I'm going to click on IP configuration. There are typically 3 times in which DHCP is going to be utilized. The first time, or one of the times, is when your computer first boots up and it doesn't have an IP address already. The second time is when you unplug the computer from a network and you replug it in either into a new network or the same network. It's going to ask for an IP address for that network. And the third time is when you manually tell it to do so. Here, by clicking on the dot next to DHCP, I'm manually telling this computer to go out there and get a DHCP address. As you can see, it did that, and the starting address was .30. Subnet mask, still the same thing that I configured the server for. And just like that, I have it. I don't have to know much about configuring them. I just set up the DHCP server, boot up my machine, and make sure it's configured to be DHCP, and away we go. Let me close out of this. Back to the logical workspace, I can hover over PC 0, and I can see by having this box pop up that it's 192.168.1.30. The /24 is letting me know that the first 3 octets are going to be used for the subnet mask. Octet 8, 3, 3 times 8, 24. However, in the real world, you won't be able to just take your hand, hover over the monitor, and sense that the address is 192.168.1.30. You would have to turn the computer on, find its way to a command prompt, and then type in the following command, ipconfig, and then hit enter. As you can tell, the same information that appeared in my Packet Tracer box also appears in this command prompt, 192.168.1.30. The subnet mask is actually listed out in a dot decimal notation, 255.255.255.0. Once again, I'm going to close out of this command prompt, and then I'm going to close out of the dialog box. Unfortunately, doing this in real-time mode has taken away the ability for me to discover exactly what happens when DHCP servers are activated. More importantly, I'm not seeing the four-way handshake that occurs for the client and the server to exchange information. The first part of this handshake is called a DHCP discovery. Second, the offer. Third, the request. And fourth, the acknowledgement. One could ask, why is there a four-way handshake and not just a two-way handshake? That is, hey, I need an IP address. Server responds with, here's your IP address. So to learn this, I'm going to switch modes. Let me come down here to my stopwatch. Now by going into this mode, I have the event list appearing. And I'm going to edit my protocol, so the only one I see is actually DHCP. So I click on Edit Filters, remove the check next to Show All/None, and place a check only in DHCP. And then I'm going to come back here and click on the logical workspace, and the only protocol that I should see visible is DHCP. To initiate this DHCP process, I can do one of three things. That is, I can reboot my computer, I could unplug my computer from the network and plug it back in, or I can manually force a release/renew process. That is, letting go what I have and asking for a new address. I'm going to choose the first option, simply rebooting my computer. Before I do that, I'm going to go into my computer, PC1 in this case, and I'm going to make sure that my PC is set to be able to get a DHCP address. So let me click on Desktop. Let me click on IP Configuration. I'm going to put a dot next to DHCP, and I'm going to close out of this. Notice when I did that, an event appeared. That's because first time you turn DHCP on, you're manually telling the computer to go fetch an IP address. Now I'm going to go back to the physical world, clicking on the physical tab, and I said DHCP can happen in 3 steps. First step is when the computer first boots up. So let me turn off the computer. Let me close out of this. You notice when I close out of my computer, the event list disappears, and then I also have the red dots and a computer that's semi-transparent. Let me click on it again. Now I'm going to click on the red power button to turn it back on. I'm going to close out of the dialog box. You'll notice there still isn't any event list yet. I have one green dot here and an orange dot here, and it looks like everything is frozen in time. This is because I'm in simulation mode. In order for things to move in simulation mode, either I hit forward, play, or go back. I'm going to do this one step at a time, so I'm going to click on the forward button. You'll notice when I do that, the light goes green, an item appears in the event list, and this computer shoots this message up to the switch. This is the first step in the four-way handshake for DHCP, and this is the discovery. Remember, this PC doesn't have an IP address. It doesn't know what network it belongs and who's on this network. So the first step in DHCP is saying, hey, is there a DHCP server out there? Is there anybody that can give me an IP address? When that happens, this message is going to be distributed out of all the ports except the port that the message came in. In plain English, this message should be copied and sent to PC0, PC2, as well as the server 1. Now only one of these end devices should actually listen to that message and respond to it, and that device being the server, because in the background the server has the DHCP service running. Let's click on forward and see if that is the case. And as it would happen in the real world, we have 3 of the same messages being distributed, but only one end device accepting it. According to the four-way handshake, the next step would be the offer. That is, the server is going to offer PC1 an IP address. Now, I say PC1, but technically, I'm in a network that is blind. They don't have IP addresses. The server can't talk to PC1 directly, which we call a unicast communication, because they cannot put the IP address of PC1 in the destination part of a packet because PC1 doesn't have an IP address. So when the server makes this offer technically goes to everybody. And there are some times out there when, ironically, somebody who was looking for an IP address could actually receive that offer that was intended for another person. It's completely blind, the server's broadcasting to everybody, and the first person who takes that offer is the person that gets the IP address. So step 2 of the DHCP process is the server making an offer to the client. The server should be telling PC1, why don't you use the 192.168.1.31 address. The other PCs are going to hear it, but because they haven't made a request, they're going to ignore it. So let's hit forward, and we see the offer being sent out to the switch. As I said, these 3 PCs are going to all receive it, but only one's going to choose to listen. Let's hit forward. There they are. As I mentioned about IP addresses, let me come over here and click on the PDU information for the last one that was sent to PC1. Now, as you can see, we have the OSI model. I have layer 7 DHCP. It came from the server, which had an address of 192.168.1.253, but the client, it has all zeros. They're like wildcards. If I look at layer 4, the source port was 67. That means it came from the server. The destination port is 68. Anytime an offer or request is made, it's being sent out of port 67. And anything that needs to be listened, to be received, like here's an IP address, try that, will come in at port 68. It's a way for the computer to know what's coming and going using DHCP without having to have any IP addresses. Also notice that the IP header, the layer 3 packet header, source IP address is the server, but the destination's all ones. 255.255.255.255. This is the classic global broadcast address for an IP network. Notice that the MAC addresses are all Fs. That's the same as saying all ones. This is the global broadcast, and when I mean global in this case, local broadcast for physical addresses. This is why the switch is able to send the message to all other devices. Let me close out of this, and now we're back to the logical workspace. The next step in this process is known as the request. When the client sends a message back to the server requesting the address that the server offered. This is a way to verify that this address is still available and nobody else on the network has snatched it. We call this a race condition. First one, first serve. So let's click on the forward button and see that request make its way up back to the server. Now remember, PC1 doesn't have an IP address. It cannot unicast to the server. When the switch receives it, it's going to be broadcast out of all the other ports. So let's click forward, see it get copied. But because none of the other devices have DHCP services running in the background, they choose to ignore it. In your home environment, if you're setting up multiple wireless networks and you bought them from different manufacturers, you might have noticed that certain computers are assigned one address and other computers are assigned another address. That is because in your network you have 2 DHCP services running, one on one router and one on the other. There's that race condition. You might want to go to one of the routers and turn it off. In this case, all I have is one server running one DHCP service. So the message is able to get back to that server without any convolutions. And now we're left with the 4th step of the process. This is called the acknowledgment. The server is going to send back a message to the PC saying, I have your name on the list for this address. This address should be 192.168.1.31. Let's see this. So let me click forward. Remember, we can't have a unicast conversation, so it gets to the switch. The switch is going to broadcast it out of all of its other ports, but only PC1 is going to choose to listen to it because of its session. And we have a green check mark indicating that the process is done. Let's verify that PC1 received the address that we thought it would. In Packet Tracer, we can hover over PC1 and see the magical box appear, and it tells us the address is 192.168.1.31. Now remember, you can't do this in the real world, so you want to click on the PC, going to the PC, clicking on its desktop tab, find a way to the command prompt, and type in ipconfig and hit enter. In doing so, we receive the 192.168.1.31 configuration for this device. So, once again, the four-step process for DHCP is discovery, then the offer that comes from the server back to the client, the request from the client back to the server, and finally the acknowledgement from the server back to the client. Even though I'm showing you this as a unicast conversation between client and server, you need to remember it does not occur. It goes to the switch will distribute out of all of its ports, bothering everybody on the network, slowing things down until this PC has established itself with an IP address. Earlier I mentioned that there are three ways of getting an IP address dynamically assigned: booting up, reconnecting, or forcing an entry. Most of the time, you don't want to reboot your computer just to receive an IP address. So in this part of the demonstration, I will show you how to go to a PC, enter a command that will release a current address, and renew for a new address. Let me click on PC2, click on the Desktop tab, click on the command prompt, and I'm going to type in ipconfig space /release and hit enter. Now it says this port is not using DHCP. Let me close out of that. Go back to the IP configuration setting and put a dot in here where it says DHCP. Let me close out of this box. And you'll notice that once I put that dot in there, I'm initiating the DHCP process, but that's not what I want to do. I want to show you how to manually do it. So I'm going to click on the command prompt and hit the up arrow because the last command that I typed in was ipconfig space /release, and now I'm going to hit enter. And now I have all zeros listed, letting go whatever information I had before, and now I'm going to type in the command ipconfig space /renew and hit enter. And you'll see at this case that I have some, let me close out of these dialog boxes, some multiple packets going on, and that is because the first time that I clicked on DHCP, I set up a packet. Next time is because I issued a command. I don't want these overlapping packets going on doing multiple things the same. So I'm just going to click Reset Simulation, go back to PC2, click on its command prompt, and then I'm going to hit the up arrow. As you can see, I actually have a .32. It shouldn't have happened. I'm going to hit the up arrow twice, hit the release, letting go of that .32 address. So it's all zeros. Hitting the up arrow twice, so I'm back to the ipconfig space /renew, hit enter, and now I can watch the simulation. So let me click auto capture /play and see this in action. And as we can see, we're looking for the discovery. I'm actually going to be sending out 2 discoveries. It's a little flaky there. I don't know why that is the way that is. And here's the discovery yet again. server receives the discovery, makes an offer. The offer gets distributed to everybody on the network. Now I might be seeing another offer again happen because I did this twice. We'll see. In this case it wasn't, at least not yet. So PC2 is now making the request, saying I would like this number, is it still available? The server is going to refill that request using acknowledgement. Yes, that number is still available. And at which time the packet should make its way back to PC2, and PC2 should have its configuration. So let me hover over PC2, and I receive the address of 192.168.1.32. Now, was it worth all this trouble of setting up a server just to dynamically assign 3 IP addresses? Probably not. But in the real world, we're not dealing with just 3 devices. We're dealing with many devices, like 30, 60, hundreds of them. It doesn't matter. The point is that DHCP offers us flexibility, especially if you have a laptop and you want to go from network to network without having to configure or call somebody up and saying, what is the gateway address, what is your DNS address, what is your IP address, or what is your network address. That can just be tiresome. And so why we set up servers is so they can automate. They're easier to manage, they're centrally located. One other perk is we can implement change a lot easier than if we had to do everything manually. The change I'm going to implement is I'm going to add a gateway, in other words a router, to this network. And in order to do so, I need to come down here to the lower left corner and click on the very first icon called routers. I'm going to click on the 1841 series router. I'm going to click right there to the left of the server, just above the switch. Now there's no need to be in simulation because I'm doing something that we normally do in the real world, and that is we change our networks according to our needs. So I'm going to change it from simulation to real time. I'm also going to just make sure that my animation's all done. I'm just going to click delete to destroy any scenarios I had going on. And now I'm going to connect the router to the switch. In doing so, you will notice that the actual router leaves its interfaces turned off by default. So right when I connect them, I have 2 red dots. And that's not a good sign, because none of the other devices on the network is going to be able to reach the router because the router's interface is turned off. So we need to turn it on, and we need to configure it. We are going to configure it with a static IP address because every device on this network will eventually want access to the router. And if that router is changing its IP address all the time, it's going to be harder for everybody to find its way out. So it becomes static. Let's click on router 0. Now in this case, we're just going to do it using the GUI interface by clicking on the config tab. We're going to click on fast Ethernet 0/0. This is the port that I have connected to my switch. And then I'm going to come up here and I see port status. And next to the on label is an empty box. I'm going to click on that so I can have it checked, turning it on. And then down here it's going to ask for an IP address. Earlier I made my server 192.168.1.253. This one I'm going to make as 254. The standard I like to follow is that the last usable address of my network is assigned to my gateway. Some people like using the first one. To each is their own. I'm going to click on the subnet mask and I get the 3 255s followed by a 0. Let me close out of that. And if all goes well, I should have green lights everywhere. This is a good thing. However, what just happened was I added a gateway, but when I hover over these PCs, their gateway field is still left empty, as well as this one, and as well as that one. So even though I added a gateway, they're not going to be able to communicate outside their network because they don't have a gateway address. They don't know what device will handle the traffic that leaves their network. In other words, these devices don't know where the front door is to their network. So let's go back to the server. Let's go over here to the left. Remember, I'm under the config tab. Let's click on DHCP. And this time, let's change the default gateway from all zeros to the router's address that we just added to our network, 192.168.1.254. Click Save. and then click close. Now you think you made that change, the other devices should receive it. But once again, they haven't received any of them. So what could I do? I can click on the device and come up here to the command prompt, type in ipconfig /release. Notice I dropped the address, and then ipconfig. Now when you do release, you're letting that address go back into pool for other people to use it. Let's type renew and hit enter. Might take a second, but now I have the gateway address implied. Let me click close out of this, and I'm going to do the same thing for the other devices. Go to command prompt, type in ipconfig release, ipconfig renew. Probably have the 31 address and then a 254 for my gateway. Close out, and finally do it with PC2. And as you can tell, all three of my devices now are pointing their gateway address to this router. Question: do we have a network? Answer: no. Remember, a network consists of two or more devices connected together to share resources governed by a set of rules. We have two or more end devices. In fact, we actually have 4. They are connected together, thank you to the switch and the cables that actually join them to the switch. They do have a set of rules that we're all using the IP on this network. However, we haven't shared any resources. Don't get lazy. Always verify things are working. So let me click on PC0. Let me click on the command prompt. Let me ping my gateway to see if things are communicating with each other. So I'm going to type in 192.168.1.254 and hit enter. And I have replies. You know, just to be thorough, I'm also going to ping the other devices on my network. 192.168.1.31, and I have 4 replies, all of which are good signs. And then I'm going to ping the last PC, 192.168.1.32, and the last device I'm going to ping is my server, ping 192.168.1.253. Hit enter. It's nice having some kind of order to your addresses so that you can go around pinging each device without having to look them up. However, as the network gets larger and larger, it becomes problematic. So I suggest people keeping journals. Document everything. They're really critical into maintaining a network. Most of the time, that's what you're doing, is maintenance. You're not creating networks left and right. In fact, stop and think about it. How often do you build a new home compared to how often do you clean your new home? So keep things documented. Know where things are at, so when you ping these, you can see where problems are occurring. This concludes our demonstration on how DHCP functions. In this particular packet tracer screencast, we learned the 4-way handshake that a DHCP service has with its client. The first one was the client making a discovery. Is there any DHCP server out there? The next step is the server responding to that discovery by making an offer. Here's an IP address. Try this out. The third step is the PC requesting to see if that IP address is still available. And the fourth and final step is the server acknowledging that request and assigning the PC with that address. Take care, and I'll see you in the next screencast.